Hi my dear friends, welcome to the new video of complex analysis on the topic harmonic conjugate. We know the real and imaginary parts of an analytic function are harmonic. What's a harmonic function? Harmonic functions are those functions which satisfies Laplace's equation and second order partial derivatives are continuous. Next, consider a function u. Let me define harmonic conjugate of u. The harmonic conjugate of u is a function v such that u plus iv is analytic. That is, if f equal to u plus iv is analytic, we say u and v are conjugates each other. That is, u is the conjugate of v and v is the conjugate of u. The term harmonic conjugate is also used in projective geometry. In projective geometry, 2 points A and B are said to be harmonic conjugates of each other with respect to another pair of points C and D if the cross ratio of A, B, C, D is -1. In geometry, the cross ratio is a number associated with a list of 4 collinear points, particularly points on a projective line. See, in this video, we are discussing harmonic conjugates in complex analysis. So here, if u and v are real and imaginary parts of an analytic function, then we can say u and v are harmonic conjugates each other. Analytic functions, harmonic conjugates appear regularly and play a fundamental role in maths, physics and engineering. Let me explain the method of finding harmonic conjugate of a given function. Here notations are: number 1, v is the harmonic conjugate of u. Number 2, u is the harmonic conjugate of v. In problems, either u or v will be given. If u is given, you have to find v. If v is given, you have to find u. Assume u is given. We have to find its conjugate. We know its conjugate is v. So we have to find v. We know by integrating dv, we will get v. So we can write v is equal to integral dv. Since v is a function of x and y, dv is dou v by dou x into dx plus dou v by dou y into dy. So integral dv becomes integral of dou v by dou x into dx plus dou v by dou y into dy. But we can't write dou v by dou x and dou v by dou y since we have to find v. But u is given, so we can easily write its partial derivatives dou u by dou x and dou u by dou y. Since v is the conjugate of u, we know u plus iv is analytic. Since it is analytic, it satisfies Cauchy-Riemann equations. So we can replace dou v by dou x and dou v by dou y in terms of partial derivatives of u with respect to x and y by using Cauchy-Riemann equations. So dou v by dou x is minus dou u by dou y and dou v by dou y is dou u by dou x. So integral becomes integral of minus dou u by dou y into dx plus dou u by dou x into dy. See, always it is the solution of an exact differential equation. So solve this differential equation by the method of solving an exact differential equation. Its solution is its integral. So here While integrating with respect to x, you have to keep y as a constant. While integrating with respect to y, you have to integrate those terms which are independent of x. That is, integral of any term containing x will be 0. See, this is the method of solving an exact differential equation. So here you apply this integration technique. And after integration, you put a constant, and that will be the required v. Next, consider another situation. Assume the imaginary part v is given. We have to find its conjugate. We know its conjugate is u, and also by integrating du we will get u. So u is equal to integral du. Since u is a function of x and y, we have du is dou u by dou x into dx plus dou u by dou y into dy. So integral du is integral dou u by dou x into dx plus dou u by dou y into dy. Again, we are trying to find u. So we can't write dou u by dou x and dou u by dou y. Since v is given, we can write its partial derivatives dou v by dou x and dou v by dou y. Again, since u is the conjugate of v, we know u plus iv is analytic. So u and v satisfies Cauchy-Riemann equations. So we can apply Cauchy-Riemann equations here. So we can replace dou u by dou x by dou v by dou y and dou u by dou y by minus dou v by dou x. So this integral becomes integral dou v by dou y into dx minus dou v by dou x into dy. Again, it is the solution of an exact differential equation. So solve the method of solving an exact differential equation. That is, while integrating with respect to x, you have to keep y as a constant, and while integrating with respect to y, you have to integrate those terms which are independent of x. And after integration, you put a constant, that will be the required u. Next, problems. Question: find the harmonic conjugate of u is equal to x square minus y square minus y. First, you find partial derivatives of u with respect to x and y. Assume v be the conjugate of u. We have v equal to integral dv, which is integral dou v by dou x into dx plus dou v by dou y into dy. By applying Cauchy-Riemann equations, this integral is integral minus dou u by dou y into dx plus dou u by dou x into dy. Separate the integrals and substitute dou u by dou y and dou u by dou x. Then integral becomes integral 2y plus 1 into dx plus integral 2x dy. While integrating with respect to x, you keep y as a constant. So integral 2y plus 1 with respect to x is 2xy plus x. Or you can consider 2y plus 1 as a constant, and its integral is 2y plus 1 into x. That is 2xy plus x. Next, integral of second term with respect to y. See, here we have to integrate those terms which are independent of x. Here the term contains x. So there is no need of integrating, and its integral is 0. After integration, put a constant c. This is our v. That is, v is 2xy plus x plus c. Next question. Find the harmonic conjugate of v, where v is cos x sin hy. Say, conjugate of v is u. So we have v. So find its partial derivatives dou v by dou x and dou v by dou y. Let u be the harmonic conjugate of v. So we have u equal to integral du, that is integral dou u by dou x into dx plus dou u by dou y into dy. Applying Cauchy-Riemann equations, this integral is changed to integral dou v by dou y into dx minus dou v by dou x into dy. Substitute the partial derivatives of v with respect to x and y suitably. Then we will get integral cos x cos hy dx plus integral sin x sin hy dy. First integral with respect to x. Its integral is, see, while integrating with respect to x, we have to keep y as a constant. So cos hy is a constant. So you integrate cos x with respect to x. Integral cos x is sin x. So its integral is cos hy into sin x. Next, integrate sin x sin hy with respect to y. While integrating with respect to y, you have to integrate those terms which are independent of x. That means integral of those terms containing x is 0. See, this term contains x. So its integral is 0. Next, after integration, put a constant c. So we have u equal to sin x cos hy plus c. One more question. Find the harmonic conjugate of v equal to 4xy minus x cube plus 3xy square and hence write the corresponding analytic function. Here v is given, so you find dou v by dou x and dou v by dou y. Assume u be the harmonic conjugate of v. We have u equal to integral du, that is integral dou u by dou x dx plus dou u by dou y into dy. By applying Cauchy-Riemann equations, we can see it is integral dou v by dou y dx minus integral dou v by dou y dy. Substituting dou v by dou x and dou v by dou y, we can see it is integral 4x plus 6xy into dx minus integral 4y minus 3x square plus 3y square into dy. First integral is integration with respect to x. So its integral is 2x square plus 3x square y minus of. Second integral is integration with respect to y. So you have to integrate those terms which are independent of x. So in this integral there are two terms which are independent of x. The terms are 4y and 3y square. So integral 4y is 2y square and integral 3y square is y cube. Also integral of the term minus 3x square is 0. So the harmonic conjugate u is 2x square plus 3x square y minus 2y square minus y cube plus c. Now we have the conjugate of v, that is u. So we have both u and v. We have to write the corresponding analytic function. We know the corresponding analytic function f is u plus iv. So f is 2x square plus 3x square y minus 2y square minus y cube plus I into 4xy minus x cube plus 3xy square plus c, which is the required analytic function. Thank you.